And this is the exam review for semester 4. The subject is physics for grade 7. Schematize an electrical circuit. So we looked at how to draw each of the components, so a lamp, battery, electrical connecting wire, motor, open switch and a closed switch. And to draw an electrical circuit, physicists use specific symbols representing the different elements of an electrical circuit. So for example, if we're going to draw something like a circuit which has a lamp, a battery, and a switch, we look at the symbols and we connect them together. For example, so a lamp, which can be either, by the way, be drawn like this. Okay, so either way you draw is fine. So we have a lamp, okay, connected to, so we always, between a component and another component, we put an electrical wire. So we've got a switch. Now here it doesn't say if it's open or closed. I'm going to do an open switch. So draw an open switch. Okay. Connected to that is the battery. Okay, so we draw a battery like this. Okay, and we connect these two. So here I've drawn an electrical circuit. Okay. So we use the symbols given to us and we just draw it. We then looked at conductors and insulators. This summarizes the conductors and insulator. For example, an aluminium is a conductor and not an insulator. A copper is a conductor and not an insulator. Wood is not a conductor, it's an insulator. And a conductor allows the passage of an electrical circuit. Therefore, if we have a circuit containing for example, a copper, which is a conductor, the lamp or the motor or any component that we have there will glow. So the lamp will glow, the motor will work because it conducts electricity. While an electric insulator does not allow the passage of an electrical current. For example, so if we have wood and we were going to see if the lamp will glow, the lamp will not glow because it's an electric insulator. Because the wood is an electrical insulator. So it does not allow the passage of an electrical current. So then we look at the relationship between the battery and the lamp. And whenever the voltage given out by a battery is equal or slightly higher or even slightly lower than the voltage needed by the lamp will glow normally. So this lamp, so for example here we've got 4.5. So the battery is 4.5 volts. While the lamp needs 4.2 volts, it uses 4.2 volts. The lamp will glow normally. Whenever the voltage given out by a battery is much greater than the voltage needed by a lamp, the lamp will glow brightly and then burn out. We say that the lamp is overdriven. So for example here the battery is 9 volts, but it only uses 4.2 volts. Here the lamp will glow brightly, okay, and then it will burn out, so it will just switch off, okay. This process called overdriven. So the lamp is overdriven. Whenever the voltage given out by a battery is much smaller than the voltage needed by the lamp will glow very dimly. We say that the lamp is underdriven. Here the voltage of the battery is 1.5, but here the lamp is 4.2 volts. So here the battery or the lamp will glow only dimly. So we always have to look at the voltage given by the battery and the voltage that the lamp uses. Measuring the intensity of an electrical current. The ammeter is an apparatus that measures the intensity of the electrical current. The ammeter has two ports, which is A for positive, so A is normally this side because it's positive, and COM. The A port of the ammeter is connected to the side of the positive of pole of the battery. So as you can see here, I wrote A here for a reason, because the A should always be on the positive side of the battery. The COM port of the ammeter is connected to the negative pole of the battery. So here you can see that the COM is always on the negative pole of the battery. The caliber of the ammeter is the maximum intensity of the current that can be measured by the ammeter. Voltage. The voltmeter is an electrical device that can measure the voltage. So when connected across the extremities of an electrical device, for example a lamp or a motor, the voltmeter measures the voltage across those extremities. Okay, so here, for example, it is measuring the voltage that is received by the lamp from the generator, which is also known as the battery. A voltmeter has two poles, so here V and positive, and COM, which is negative. And just like we saw with the ammeter, the V has to be in line with the positive part of the battery, and the COM has to be in line with the negative part of the battery. When a voltmeter is connected in parallel to certain electrical device, the voltmeter would measure the voltage across the device. The voltmeter has several calibers. Electrical appliances connected in series. So as you can see in this figure, these are all connected in series. This is because the circuit is made out of one loop. So here you can see there's only one loop. All of the electrical appliances are connected one after the other. So we've got the battery, then we've got the switch, then we've got the lamp, and they function together. Whenever one stops, for example, if the battery stops working or the switch stops working, or if we have two lamps here, we've got two lamps here. Okay, so imagine there's another lamp connected here. If this one switches off, so if this L1 switches off, okay, L2, the lamp 2 will switch off too. The current transversing appliances placed in series has the same intensity through the circuit. So the ammeter reading, if we also have an ammeter reading here, this will be the same throughout the loop. This is the law of uniqueness of the current in a series circuit. Whenever the appliances are connected in series, their voltages are additive. The brightness of the identical lamps connected in series diminishes as the number increases. So, for example, if we have 5 lamps, they will glow dimly. But if we have, for example, 2 lamps, they will glow more brightly. Batteries connected in series and opposition. The positive pole of the battery is connected to the negative pole of the other identical battery. So here you can see the positive is connected to the negative pole of the identical battery. Those two batteries are said to be connected in series. So when we have minus plus, minus plus, minus plus, this is connected in series. The voltage of the batteries placed in series are additive. For example, if I have this battery is 3 volts and this battery is 3 volts, the circuit has 6 volts. The battery is giving out 6 volts. However, here, when the negative pole of a battery is connected to the negative pole of another identical battery, so as you can see it's plus, positive, negative, negative, positive, okay? Those batteries are said to be connected in opposition. So here you can see it's positive, negative, negative, positive. This is an opposition. The voltage of batteries placed to opposition are subtracted from one another. So for example, if I have here, let's use 3 volts again, 3 volts. Here we have 3 volts. Altogether we'll have 0 volts. Okay, so here we'll have 0 volts. Electrical appliances connected in parallel. Whenever two appliances are connected in parallel, every appliance can function independent to the other. Okay, so for example, if here we have a battery, okay, and it's got a switch, and the switch is now going to be closed. Okay, and we've got a lamp here. Okay, and another lamp here. Okay, so these are connected in parallel. Every appliance can function independent of each other. Means if this lamp L1 switches off, L2, this lamp L2 will stay on, and vice versa. So if L2 switches off, L1 will keep on going. Okay, this is opposite to lamps connected in series. This parallel circuit is made of several loops. So here we've got one loop, okay, and here we've got another loop. The voltage across the two appliances connected in parallel are equal. This is the law of uniqueness of voltages. So for example, if here I've got the batteries giving out 3 volts, L1 will have 3 volts and L2 will have 3 volts. The sum of the current intensities arriving to a junction is equal to the sum of current intensities leaving the same junction, and this is for the ammeter reading. Now we are going to solve the questions for the exam review. Question 1 says, we have an electric circuit of the following components: closed switch, dry cell, remember dry cell means battery, connecting wires, and 2 lamps in series. So the first question says, draw a diagram of this circuit. So we have a closed switch. Let's draw that first. Okay, so we've got a closed switch. Okay, so it's closed. Okay, we've got a battery. Alright, and then we have 2 lamps in series. Okay, so this is 1 lamp. Because it says in series, that means they are next to each other. Okay. Alright, so this is how we draw this. Connect a voltmeter to the dry cell to read its voltage. So this is not, the voltmeter is always parallel to the component you want to measure. And then it says show on the diagram the direction of the current. So the current flows from the positive to the negative. So any arrow, so you look at the battery here, this is positive, so it flows from the positive to the negative, which is here. Okay, so this is why I drew the arrow in this direction. If the dry cell has a voltage of 12 volts and UL1 has a voltage of 4 volts, find the voltage of L2. So you do U equals U1 plus U2. So the dry cell has a voltage of 12 volts, so that's U. We know that the L1 is 4 volts, so we need to find L2. So we just rearrange the equation. 12 minus 4 equals U2, which is 8 equals U2. So U2, which is lamp 2, has 8 volts. Now it says L1 has a rated voltage of 6, while L2 has a rated voltage of 4. Describe the brightness of each lamp. Now, we know that the first lamp, let's concentrate on L1, it has a rated voltage of 6. However, it's receiving from the battery a voltage of 8. Now, 6 and 8 is not that far from each other, so it will glow normally. So for L1, the lamp will glow normally. Now let's look at L2. L2 has a voltage of 4, but it's receiving 8 volts from the battery. Now, there's a big difference between 4 voltage and 8 voltage, so we expect the battery will glow brightly. However, the lamp will be overdriven and it will quickly turn off. So L2, because the rated voltage is 4, and the voltage that it's receiving from the battery is 8 volts, which is much higher than the voltage of the lamp. The lamp will grow brightly, but however this won't stay for long. It will switch off, it will burn out. Due to it having a higher voltage. What's the difference between electric insulators and electric conductors? So remember, electric insulators does not allow electric current to flow through it. While electric conductors allow electric current to flow through it. Classify the following substances into electric conductors or electric insulators. Classify them to justify. So conductors are the ones that allow electric current to flow through it. Insulators do not allow electric current to flow through it. Okay, so we've got we've got nylon. Nylon is an insulator. Silver is a conductor. Just going to change the color here because you can't see it properly. Air is an insulator. Plastic is an insulator. Wood is an insulator. Glass is an insulator. Aluminium is a conductor. Gold is a conductor. And graphite is a conductor. While porcelain is an insulator. A diagram of an electric circuit is shown in the adjacent figure. Give the name of the components of the circuit from 1 to 5. So number 1 is here. You can see this is an open switch. Number 2 is here. You can see that number 2 is a battery. 3 is here. You can see that number 3 is connecting wire. Number 4 is here, so that's a motor, and number 5 is here, this is a lamp. Component 5 of the above figure does not glow. Why? So this lamp does not glow. Why? Because the circuit, as you can see, is open. Because the switch in particular is open. In order to make the lamp glow, we need to make a change in the above circuit. What is the change? So we need to close the switch. Okay, because the switch is open, we have to close the switch. It says redraw the above figure showing the change. So here we're going to draw the switch closed. Okay, so there's a switch, then we have a battery. Okay, then we have the motor, then we have the lamp, then we've got this object W. But we don't know what it is yet. And then says, after making the change, the lamp also does not glow. Propose a justification. Now, what we have to work here with is object W. Now, object W, we don't know what it is, so it could be an insulator and it can be a conductor. We're going to assume now it's an insulator because the lamp does not glow. Okay, so we can say object W could be an insulator. Remember, an insulator means it does not allow electric current to flow through it. Okay, could be an insulator. Question 4 says, a 7th grade student formulates the following hypothesis. The brightness of two identical lamps does not vary when their grouping across a dry cell varies. To verify this hypothesis, he builds two electric circuits A and B using a 12-volt dry cell, two identical lamps L1 and L2, a switch and connecting wires. The adjacent diagram represents the electric current A built by the student. How are L1 and L2 connected across the dry cell in circuit A? So this is L1, this is L2, and you can see that they are across each other, therefore we call this in parallel. So here we can write in indicate while justifying the voltage across L1 and L2. Now, because they are connected in parallel, okay, so the voltage that they will receive is 12 volts each. So 12 volts will come to L1 and 12 volts will go to L2. This is called the law of uniqueness, okay? So, because the lamps are connected in parallel, both lamps receive 12 volts. This is known as the law of uniqueness. The student changed the connections of the components of circuit A to obtain circuit B represented below. So how are L1 and L2 connected across the tri-cell in the circuit? This is L1 and this is L2. They are together, so this is in series. Okay, so when they're next to each other, it's in series. Indicate while justifying the voltage across L1 and L2. Remember that L1 and L2 are identical lamps, each of rated 12 voltage. So U equals U1 plus U2, they are identical, so it's 12 divided by 2, so 6 volts. So each lamp has 6 volts. Each lamp is receiving 6 volts. Deduce while justifying the brightness of L1 and L2. Here it says the rated voltage is 12 volts, but it's only receiving 6 volts. So it will glow dimly because it will glow dimly because the rated voltage is 12 volts and it's only receiving 6 volts. Question 5 says a student uses identical 12 volts incandescent lamps and two 12 volts dry cells to build up the following circuits. What does the 12 volts on the lamp represent? So it is the voltage it uses. Okay. How are the lamps in circuits A and B connected? In A, they are next to each other, so that is in series. Circuit B, so you can see here these are in parallel. Give the name of the instrument that measures the voltage of the dry cell, and that is called a voltmeter. We use a voltmeter to measure the voltage. Determine the voltage across each lamp L1, L2 and 3 in each of the circuits. Okay, so we know that the battery is 12 volts and we know that these are identical. So U equals U1 plus U2 plus U3. So it's 12 divided by 3, which equals 4 volts. So each lamp is receiving 4 volts from the battery. In case in circuit A, okay? However, in circuit B, for parallel, okay, they will each receive 12 volts. They will each receive 12 volts. Indicate with justification in which circuit the lamp glows normally. Now, each of these lamps are receiving 4 volts, but to glow normally, they need 12 volts. So here they are glowing dimly. With here, as you can see in circuit B, each is receiving 12 volts, and to glow normally they need 12 volts. So it will be in circuit B, because the rated voltage is the same as the voltage they are receiving. Give a disadvantage of the connection of lamps as in circuit A. Now with circuit A, which is this one here, problem with this, if one of these lamps turn off, they will all turn off. So if L3 turns off, L2 will turn off, and L1 will turn off, because there's a gap in the circuit, because it's in a circuit in series is like in, it is only one loop. Okay, so if one turns off, all the others will turn off. However, with parallel, if this one turns off, for example, L2 and L3 will stay on. So if one burns out, all of the other lamps will turn off because the lamps are connected in series.